Hey guys, we're back for lesson 9.5, mean absolute deviation. You'll see in green below there, I know it's kind of shiny, but it says MAD, and that is the abbreviation for mean absolute deviation. For you period 1-2 people, remember how we recorded this together? Unfortunately, the recording did not upload properly, so I'm having to remake this. So if it sounds a little different than it did, that's because I kind of make it up as I go. Alright, so this idea of mean absolute deviation is related to the idea of quartiles and interquartile range. We're looking to try to figure out how spread out our data is. Okay? So the nice thing about MAD is there's 4 specific steps that you need to follow. First you find the mean, and we're all really good at that now. We just add up the numbers, we divide by the number of data values, and bam, we got the mean. The next step that's a little tricky is we have to find the distance between each data value, each number, and the mean that we calculated. So let's say that our mean we calculated was 10, and in our data set we had the numbers 5, 7, 11, 14, etc. I'm going to take 10, the mean, and subtract 5, then I'm going to subtract 10 minus 7, then I'm going to take 11 minus 10, so I'm taking the higher number minus the mean. When the lower number, I take the mean and subtract that lower number from it. Eventually, I will get another set of 10 numbers. I'm going to add those up in step 3, so all those distances from the mean added up from step 2. And then I'm going to go back and I'm going to divide by 10 again because that's the number of data values I have. So that 4th step, but when we divide, we're basically dividing again to figure out how far does our data spread out, okay? I don't have my remote mouse today, so my camera's going to kind of slide around, so I'll be back. Come on back with me, Swivl. Come on. Swivl doesn't want to come with me. There we go. Come on, little Swivy. He's kind of like my dog. Not real smart, but he's okay. All right. So here we go. We have a typical set of data. So this is, I asked 8 people, what's the age of your youngest sibling? And I got the answers 5, 8, 8, 10, 13, 14, 16, and 22. So to get that mean, I added up all the numbers in blue to get 96. There are 8 people I asked, so I divided by 8, and I got a mean age of 12 years old. Now down below in black, if you look real closely, I took 12, the mean that I'd calculated, and I subtracted 5. Right below the 12 minus 5, I put the number 7. And then I did that with every single number in my data set. So in black, I did 12 minus 8 again, then subtracted 10. Then I flipped it over because 13 is bigger than the mean, so I did 13 minus 12. I want to keep my numbers positive so I don't start getting into positive and negatives and adding, and so we don't want to take that smaller number and subtract a bigger. Eventually I did all 8 and I got 34 after I added up all the numbers in red. I still have 8 data values, so I divided by 8. And 34 divided by 8 is 4 25/100ths. So my mean absolute deviation is 4 25/100ths. Basically what that means is I don't have a real huge spread here. My lowest number is 5, my highest is 22. I don't have a sibling that's like 50. That would change my mean absolute deviation considerably because an outlier affects the mean, which in turn will affect the mean absolute deviation. Alright, that's all I got for today, guys. We will see you tomorrow. We will work on this in class, and we'll see how we're doing. If we need an extra day, we'll take that Friday, and we'll take our quiz on Monday. Peace out.